we'll go ahead and switch over into our next presentation titled, sorry, make sure I'm on the right one, Organics Processing Facilities, Traffic Simulation Analysis. Zheng Liu and Rohan Shetkar from Stantec are presenting. A little intro, Zheng's transportation engineer based in Stantec's Edmonton office. And has a lot of experience doing transportation planning and operations, roadway geometric design, and various transportation modeling projects. Zheng, we thank you very much for being here today, along with your colleague Rohan, who is based in Stantec's transportation engineering team in Pune, India, and who has done a lot of different work worldwide. Your bio is very impressive there, and the number of countries you've worked in. That's really cool. A lot of experience in microsimulation and travel demand modeling, pedestrian modeling, signal optimization. So perfect. We welcome you both today, and we look forward to your presentation.
Thank you. Thank you. Thank you so much. So first of all, good morning, good afternoon, everyone. And first of all, I want to thank PTV give us this opportunity to present our traffic simulations analysis project. Today, we will present a traffic simulation analysis by using PTV Vissim for design organics processing facilities in Canada. So my name is Zheng Luo. I'm a transportation engineer who is working with Stantec Edmonton office in Canada. My co-presenter is Rohan, who is working with the Stantec Pune office in India. So for this organic processing facility design project, it was managed by our Stantec water resource team in Canada. As an important design component, Stantec transportation team was involved in to conduct this traffic simulation analysis. And I was the one to take in charge of traffic operation analysis, and Rohan took in charge of Vissim modeling analysis. Next slide. So based on our presentation agenda, this presentation will include 6 parts. I will present the first 2 parts, project background and scope, and Vissim model inputs, as well as the last part, which is about project conclusions. Rohan will present the core parts in terms of Vissim modeling, including modeling challenges, planned solutions, Vissim microsimulation runs and output, and modeling results and deliverables. Next slide. So this is our project background and scope. For this organics processing facility design project, one of the main tasks is to design the waste collection building based on the existing site condition. As shown in this image above, trucks that unload waste will enter the site along the service road from the bottom right of this image, and then line up in the waiting lanes at the entrance. Once any unloading bay is available, a truck will enter the processing area, which is adjacent to the unloading bays, by turning left and then reverse to unloading waste. Once the unloading process is done, this truck will directly use a single lane exit and then turn left to drive along the service road again to leave the site from the same direction to enter the site. So for the scope of this project, we would like to use PTV Vissim to test the proposed circulation plan. And secondly, we will simulate the traffic operation to calculate the maximum truck waiting time and waiting queue length at the site entrance. And last but not least, we will identify the potential queue spillback to the service road. Next slide. So for the Vissim model inputs, we prepared the proposed site conceptual plan, which is several AutoCAD files, and they were used as a Vissim model background, which was inputted in the model. In this plan, unloading bay locations, vehicle circulation area, truck queuing area, queuing lane locations, and exit lane locations were marked up in the drawing. And then in addition, Vissim model will follow the proposed traffic circulation routes and recycling routes, which were proposed by our water resource team and the transportation team. And they were described already in the previous slide. So next slide. So this is our Vissim model inputs, mainly about the data. So the data we inputted in the Vissim model, we have the several assumptions. First of all, we assume the operation time on site will last 7 hours from 9 a.m. to 4 p.m. per day. Secondly, we use the 2 types of trucks for this simulation, including a WB15 truck and a general garbage truck. And the WB15 has a length of 16.7 meters, and the general garbage truck has a length of 10.2 meters. And thirdly, for the traffic volume, we assume that there will be 1 WB15 truck per hour and totally 173 general garbage trucks in this 7 hours. So during this operation 7 hours, in the AM peak, between 10 to 11 AM, there will be 26 trucks to complete the unloading process. And during the PM peak, between 2 PM and 3 PM, there will be 69 trucks to complete the unloading process. And for the other trucks, they will be distributed in each hour to the site based on the client's information. So for the modeling, we tested several scenarios based on different numbers of unloading bay numbers and queuing lane numbers. So the final design on those numbers will be determined based on the VSIM modeling results. For each queuing length, it can accommodate 3 trucks before making the truck spill back to the service road. And the last, we assume there will be only 1 exiting lane for truck to leave the site. And then I will pass to my colleague, Rohan, to introduce the detail of the modeling.
Hello, everyone. Now let's get into the details of VISIM modeling. I'll first explain the challenges that we faced and the solutions that we came up with for those challenges. And later we'll see the implementation of these solutions in the VISIM model and the simulation. So many of you might have used earlier versions of VISIM where modeling reversing vehicle was quite challenging. Modeling reversing vehicle involved creating exact link geometry and replicating it for all the such parking locations. So the solution for that is using the latest VISIM version, and it became very easy to model the reversing movements. We use parking direction attribute and set it to forward reverse in this model where we are able to use simple link geometry without much complications. The next challenge was to allow only 1 truck to use 1 bay. In case of parallel, perpendicular, or angled parking, VISIM's inbuilt capabilities direct vehicle only to the available bay. That's what I observed so far. And in this case, we needed to use reverse parking, and trucks were unable to identify available bay with a combination of reverse parking. So we observed instances like multiple instances of trucks trying to get into the same parking lot and then blocking each other in doing so. To mitigate this problem, we use ComScript using Visual Basic and kept a track of bay availability. This information was used to direct each entering truck to the empty bay only. Now that we have made sure the truck is directed only to the empty bay, the next task at hand is to direct it to the nearest empty bay. Continuing the use of COM interface, we created parking routing decisions for each combination of entry lane and parking bay. And we are setting parking rate dynamically using COM depending on the availability of parking bay. So after solving these challenges so far, we have ensured that only 1 truck will be allowed to go in a given parking space, and the truck will be directed to the nearest available parking space. The next challenge is to model the first come first serve at the facility entrance. So we implemented the first come first serve based on the truck arrival time at the entrance, that is at the stop line. In the COM script, we are noting down the arrival time for each truck and then using this information to decide which truck will be allowed to enter the bay next. And the last challenge that we faced here was to achieve uniform queuing at the entrance. Usually we can expect fairly uniform queuing by default in VISIM. And in this case, we couldn't find much space for trucks to maneuver there and the change lanes to achieve uniform queuing. So, and the primary aim of this project was to check possibility of queue overflow onto the service road. Therefore, achieving realistic queuing was very important here. So we again use the COM interface to use relative flows and static routes to direct trucks into the correct parking into the correct waiting lane. So in the last slide, we discussed challenges faced and the solutions. So here is a pseudo flowchart depicting the implementation of those solutions discussed. This flowchart will be run for each timestamp. So keeping the notations that we use for VisWap, this is a flowchart that we have prepared. So first of all, we'll be checking if there is any vehicle waiting at the entrance. In the first iteration of the script, we use indirect attribute of link to detect the presence of vehicles at the specific location. But after a few tests, we observed that detector object and its attributes are better choice for this purpose. So coming back to the flowchart, if no vehicle was identified at the entrance, then we'll check for the vehicle at the exit. If you don't find the vehicle there as well, then we'll move to the next timestamp. Now let's see the process when there is a case that we detect the vehicle at the entrance. So when a vehicle is detected at entrance, we'll check for the bay availability, and if there is no available bay, then we'll again move to the next timestamp. If the bay is available, then we'll allow the truck to enter and direct it to the nearest empty bay. And while doing so, we'll make sure that the vehicle which had arrived earliest at the stop line will be allowed to go in. So whenever we detect the vehicle at the exit, we'll get the corresponding bay number and mark it as available so that it will be used by the next vehicles. So let's see the implementation of this flowchart in the Vism. So let's take first look at the arrival. As soon as a truck arrives at the stop line, its arrival time is recorded, which we'll be using later to model the first come first serve. And whenever a vehicle is detected at the exit, we mark the corresponding bay as available. And so here the blue truck we found at the exit, and then we marked the corresponding bay as available. So please note here that the gray colored truck that we saw here at the entrance, it had arrived before the blue ones. And this information we'll be using in the next slide when we allow truck to enter. Now that there is a waiting truck at the entrance and one bay is available, we need to allow one truck in. So the truck which arrived first at the entrance is a gray colored truck, and we set the signal in front of this vehicle to green and then set parking rate for the corresponding parking routing decision to 100% to direct it to the nearest available bay, which is the bay number 1 here. So for a moment, the green signal is given for the vehicle, and the vehicle is at the correct location now. And as soon as the vehicle is assigned a bay, we mark that bay as occupied so that no further vehicle will go into that bay. So now that we have looked at the simulation, we can take a quick look at the object placement in Vism. So on the left-hand side, we can see the use of multiple parking routing decisions to direct the vehicle from a given lane to the particular available bay. And on the right is an implementation for the lane selection, waiting lane selection for uniform queuing. Because of a constrained space, we needed to use this static routing for that purpose. Now let's take a look at the simulation video at the peak time. You may observe uniform queuing component in this video, which was not that visible in the earlier video. Every time a vehicle is allowed to enter facility, we are directing it to the nearest available bay and making sure that the first come first serve is implemented based on arrival time at the stop line. In the simulation, script is deciding and directing vehicles to correct bays. In the proposed operations, a system will be in place which will notify trucks the bay number that they're allotted. Alternative to that will be a traffic warden who will supervise the operations and direct the vehicles. So we simulated the model for 7-hour analysis period, which covered 2 peaks that are expected, and results we get from the simulation are here. The maximum queue length that we observed was 44 meters, which indicates that the vehicle queue does not spill over to the service road. and we observed the maximum queue during the PM peak, and the queues were observed for a short duration of 15 to 20 minutes. Another important output was maximum waiting time, which in this case is just below 15 minutes. And both of these results were found to be within the acceptable range. So we presented model simulation video to the client, which helped client visualize the proposed operation and improve the confidence in the design. For the next part of the presentation, I'll hand over back to my colleague, Zheng.
Yeah, and for the project conclusions, we just have a multi scenarios in terms of waiting lane numbers and unloading bay numbers were tested in the VSIM model we established to see the maximum queue length and waiting time. And those results were used to discussion with the water resource team and the client. Since no spillback to the service road is allowable, so finally 5 waiting lanes and 6 unloading bays were recommended based on our model results, and there's no conflict to the site space. Then final design of this site was confirmed based on the guide of VSIM simulation results. For our client, the client is not familiar with the PT VSIM simulation tools. So we generated the VSIM modeling video clip, like Rohan said, and then we sent to the client to help the client understand the whole modeling process clearly. And we received a great response for the quality of deliverables. Last, we want to see this is another traditional PTV translation project to simulate for example, like the performance traffic of a traffic network or LRT operation. But for this multidisciplinary project, Stantec's water resource team and the translation team coordinated and communicated well to get this analysis done. And also Stantec's transportation team members in Canada and India also worked together to complete the whole micro simulation analysis. So it was a great teamwork experience to complete this analysis with the satisfaction from our client. And this is the end of our presentation. So if you have any questions, please send to us and we would like to answer. And thank you so much.
Great, thank you, gentlemen, for the excellent presentation. I'm looking at our question the list. I don't see any typed currently, but while you're on the line, if anybody still has a question, feel free. Sorry, here's the first one. How do you model trucks entering bays? Is a truck finding whatever empty bay when it's available? Maybe you can expand that a little bit on how you were modeling that.
Sure. Am I still sharing the screen?
Yes.
Okay, yeah, okay, all right. So each truck can go into all, from each lane, vehicle can enter all bays, but we are deciding which one to be used based on the parking rate, and if the particular bay is available and that's closest, then we set parking rate to 100% dynamically using ComScript to make sure that the vehicle goes to the nearest available parking bay. And whenever there is no available bay, we just keep the vehicles waiting here using the signals. So this way we are making sure that only one vehicle, whenever there is available bay, then and only then we allow vehicle to enter the facility. I think this should help to answer the question.
Yep. Yeah, thank you very much. All right, well, with that, I know we're tight today on our time frames. Thank you very much for your presentation and answering the question. If there's any others that come, feel free to enter the questions. We can pass those along later in the day. Otherwise, thank you both. We appreciate your participation.
Thank you so much.
Hope you enjoy the rest of the UGM.